Welcome to session 5 of UNIT-3 in learning the course Design and Analysis of Algorithms. In our previous sessions, we've seen various applications related to the algorithm design technique, dynamic programming. We've seen multi-stage graphs, optimal binary search trees, matrix chain multiplication. Now, in our today's session, we are going to explain about 0 by 1 knapsack problem, which can be solved by using dynamic programming. The main objectives of this session are to understand what is knapsack problem, to solve 0 by 1 knapsack problem by following dynamic programming. The learning outcomes of this session are, by listening this session, one can understand what is knapsack problem and able to follow dynamic programming strategy to develop algorithms for solving knapsack problem. The topics that we are going to discuss in this session are 0 by 1 knapsack problem statement, merging rule and purging rule, the algorithm which is developed by following dynamic programming, and an example problem or an example application. Coming to the problem statement, we already know the knapsack problem statement. We discussed it in our earlier sessions while we are talking about greedy method. What is the problem statement? Given n objects, let us say those objects as x1, x2, so on, xn. Each object xi is associated with a weight wi and a profit pi. Also given the capacity of knapsack m. If any object is placed into the knapsack, then its profit can be earned. If any object is placed into the knapsack, its profit can be earned. The knapsack problem is by placing which objects into the knapsack, we can earn a maximum profit by satisfying the constraint that the total weight of the objects placed into the knapsack is less than or equal to the capacity of knapsack. In our previous session, what we discussed in case of knapsack problem is the value of xi may be either 0 or it may be 1 or it lies between 0 and 1. Here the xi value is either 0 or 1 or it lies between 0 and 1. That is, we can place a fraction of object into the knapsack in case of greedy method. That problem is called as fractional knapsack problem. That problem is called as fractional knapsack problem. But in this dynamic programming, we are discussing 0 by 1 knapsack problem. What is this 0 by 1 knapsack problem means? It not allows fractions of the objects placed into the knapsack. We can place an object completely into the knapsack or we cannot place an object into the knapsack. So that's it. That is, the xi value is either 0 or xi value is 1. It not lies between 0 and 1 in case of this 0 by 1 knapsack problem. So I hope you all understood the difference between fractional knapsack and 0 by 1 knapsack. In case of greedy method, we are solving fractional knapsack problem. There we can place a fraction of the object into the knapsack, that fraction of profit that we can earn. But in case of dynamic programming, we are going to solve 0 by 1 knapsack problem. There it not allows placing the fractions of the objects into the knapsack. We can place an object completely or we cannot place an object. So the xi value becomes either 0 or 1. Fractional values are not allowed. So here the 0 by 1 knapsack problem is to place the objects into knapsack in such a way that the total weight of the objects placed in knapsack is less than or equal to capacity of knapsack and total profit earned must be maximum. So this is the problem statement of 0 by 1 knapsack problem. If xi is equal to 0 means the object not placed into the knapsack. I already said you that. If xi equal to 1 means object completely placed into the knapsack. Fractional values are not allowed here. So that is half of the object or 1/3 of the object or 2/3 of the object. We cannot place any fractions of the object. Whether we can place complete object or we cannot place that object. Now here the constraint is Wixi less than or equal to m. Sigma Wixi should be less than or equal to m, and our objective function is sigma Pixi must be maximum. The time complexity of 0/1 knapsack problem is big of W into n. Here W is the maximum weight and n is the number of objects. W is maximum weight and n is the number of objects. Now coming to example of this one 0/1 knapsack problem. Here I given some objects, 3 objects. Let us say those 3 objects are x1, x2, x3. The profit of first object is 60, second object is 100 and third object is 120. The weight of first object is 10, second object is 20 and third object is 30, and the capacity of knapsack is given as 50. Now which objects that we can place into the knapsack to get the maximum profit? Now here suppose if we place x1 only, the first object only into the knapsack, then what the capacity it occupies? It occupies 10. And its profit, what the profit that we can earn? 60 is the profit that we can earn. Now, if I place only x2, in that case, what the weight it occupies? 20, and what profit that we are getting? 100. If we place only x3, it occupies 30 weight or 30 capacity in the knapsack, and the profit that we can earn is 120. Now, if we place 2 objects that are x1 and x2. So the total weight occupied is 10 plus 20. x1 weight is 10 and x2 weight is 20. 10 plus 20, which is nothing but 30, which is less than or equal to the capacity, that is nothing but 50, and total profit earned is 100 plus 60. And if I placed x2, x1, x3. So here the weight of x1 is 10 and weight of x3 is 30. 10 plus 30, total capacity occupied is 40, which is also less than or equal to 50, and the total profit that we can earn is 120 plus 60, which is nothing but 180. If I place x2, x3, now the total weight occupied is 30 plus 20, which is nothing but 50, and total profit earned is 120 plus 100, which is nothing but 220. Now if I consider 3 objects to place into the knapsack, the total weight becomes 60, which is greater than 50. So it is not a feasible solution. Here I represented all these 6 are feasible solutions. Out of these 6 feasible solutions, this gives the maximum profit. So the solution for this problem is 0, 1, 1. That is x1 value is 0, x2 value is 1 and x3 value is 1. Now let us observe the total weight. Sigma W1 x1 plus W2 x2 plus W3 x3, which is nothing but W1 value is 10 into 0 plus 20 into 1 plus 30 into 1, which is nothing but 50, which is equivalent to the capacity of knapsack. In the same way, total profit also we can calculate P1 x1 plus P2 x2 plus P3 x3. Now here P1 is 60, but x1 value is 0, 100 into 1 plus 120 into 1, which gives 220. This is the maximum profit earned. Now, since we given only just 3 objects, we can easily solve the problem. But if we give more objects, we need to follow an algorithm, which is developed by using dynamic programming. Before going to know the algorithm for solving 0/1 knapsack problem in dynamic programming, we need to know 2 rules. What are those 2 rules? The first rule is merging rule and second rule is purging rule. What about those rules? Let us see here merging rule. What is merging rule? The merging operation is used to obtain Si plus 1 from the sets Si and S1I. Here S is a set. I represented one set as Si plus 1. Here I represented one set as Si plus 1 and here I represented another set as Si S1I. Now here if I first I found Si, later I found S1I. By combining these two sets, will get a set Si plus 1. So, the merging operation is merging of these two sets. The merging of these two sets gives Si plus 1, which is another set. Now, for example, let us take if Si is equal to 0, 0, Si1 is equal to 1, 2, then Si plus 1 is equal to merge of Si plus 1. That is nothing but 0, 0 and 1, 2. Just simply merging is nothing but combining the values. Okay, this is merging rule. Next, what is purging rule? Let us see purging rule. The purging rule is used to eliminate the pairs that are giving less profit with increasing more weight. Here the purging rule. What the pairs that we are representing here are, these are profit weight pairs. These are profit weight pairs. Here this is P0, W0, P1, W1, P2, W2. Like that we are writing profit weight pairs. Now here the purging rule is used to eliminate the pairs that are giving less profit with increasing more weight. If you compare two pairs, so out of those two pairs, one is having less profit with more weight, then there is no use with that pair. We cannot include that object which gives less profit with more weight. So, we can eliminate that pair. So, for eliminating those pairs, we are going to use purging rule. Now, that is, if a set Si plus 1 contains two pairs Pj, Wj and Pk, Wk with satisfying the conditions Pj less than Pk and Wj greater than or equal to Wk. That is, here this is the first pair and this is the second pair. Here Pj is less than Pk, that is profit is less. This pair contains less profit, but its weight is more when compared to that of the next pair. So that's why we can eliminate the pair Pj, Wj. That is called as purging rule. So for clearly explaining this, I have taken an example here. Let us see. The pairs are 0, 0, 1, 2, 2, 3, 3, 5, 4, 3, 5, 5, 6, 6. If you observe these two pairs, here the profit is less when compared to this one. Here let us take this as Pj and this as Wj, Pk and Wk. Here Pj less than Pk, that is 3 less than 4. Wj greater than Wk, so that is or equal to Wk. Here Wj is 5 greater than or equal to Wk. So here this pair reduces the profit with increasing weight. So we can eliminate the pair 3, 5 from the set. This is purging rule. In our algorithm, we are going to implement these two rules, merging rule and purging rule. Now, let us see the algorithm for knapsack problem using dynamic programming. See the algorithm first. Algorithm dynamic knapsack problem NPWM. Here we are passing 4 parameters to the algorithm. The first one is N, which is nothing but number of objects. P and W are profits of and weights of N objects respectively, and M is capacity of knapsack. Now, initially, we initialized a set S0 with 0, 0. That is, we are not placing any object into the knapsack. Initially, there is no any object in the knapsack. So, the earned profit is 0 and occupied capacity is also 0. So, the profit weight pair is initially 0, 0. From later onwards, we are going to calculate the profit weight pairs for each alternative. Suppose if I placed only the first object, if I placed only the second object, if I placed only the third object, if I placed the first and second objects, if I placed second and third, if I placed first and third, if I placed three objects, so what becomes the profit weight? Now we are going to find the profit weight pairs for each case. Now let us see, for I is equal to 1 to 4, what I am doing? S1 I minus 1 I am finding. S1 I minus 1, how I am finding? It becomes a profit weight pair. It becomes a profit weight pair in which P minus Pi, W minus Wi must belongs to the set Si minus 1, and the W value should be less than or equal to capacity of knapsack. Now order the pairs such that the profits in increasing orders. After finding this set, we need to order the pairs such that profits in increasing order. Later we are going to use merging and purging rules. So, to get the set Si from the sets Si minus 1 and S1 I minus 1. So, after that, after finding all these sets, we are going to find which objects is placed into the knapsack. Which object is placed into the knapsack in a bottom up way. For I is equal to n to 1, we are going to find which object is placed into the knapsack. Now, let us see how to solve a problem by following this algorithm. Here, to solve a problem, I have taken an example here. I given n is equal to 3. Here, that is 3 objects I given. The weights of those 3 objects are 2, 3, 3. And the profits of the 3 objects are 1, 2, 4, and capacity of knapsack is given as 6. Now, according to our algorithm, first we have to initialize the pairs with S0 with 0, 0. Later on, we need to find the pairs S1, S2, S3. So, how I can find these 3 pairs S1, S2, S3? That I am going to explain. Let us see how to find that one. So, initially S0 is equal to 0, 0. Now, for I is equal to 1 to n, that is 1 to 3. Since n value is 3, 1 to 3. How many values are there for I? I takes 3 values, 1, 2, 3. Now, first I am taking I is equal to 1. In that case, S1, I value is 1, that is 1 minus 1, that is equal to S1, 0. Now, what becomes S1, 0? What becomes S1, 0? How to find the set S1, 0? Now, let us see how to find that set. It is a profit weight pair. It is a profit weight pair. But what the condition it has to satisfy? P minus Pi, that is P minus Pi is P1, comma, W minus Wi, that is W1, should belongs to which one? Si minus 1, that is S1 minus 1, which is nothing but S0. This pair, that is by subtracting P1 from P, by subtracting W1 from W, we need to get a profit weight pair which is present in S0. S0 contains how many pairs? Only one pair, which is nothing but 0, 0. That is, by subtracting P1, W1 from PW, we need to get 0, 0. So, that is P minus P1, W minus W1 should be equal to 0, 0. Definitely. Now, P minus P1 is equal to 0, W minus W1 is equal to 0. That is, P is equal to P1, W is equal to W1. Hence, what becomes the pair? P1 comma W1. Now, what is this? What is the problem here? What is the value of P1 I given? P1 is 2, P1 is 1, W1 is 2. P1 is 1 and W1 is 2. 1 comma 2. Here the profit weight pair that I am obtaining in this set S1 0 is 1 comma 2. Now after that SI is equal to merge purge of Si is equal to merge purge of Si minus 1, that is S0 comma S1 0. That is, we need to merge these two. That is, here S1 is equal to S0 contains a pair 0 0, S1 0 contains a pair 1 2. So, here we will get S1 as 0 0 1 2. You can see this one here. S1 is equal to 0 0 1 2. In the same way, I can find S2. So, how to find S2? Here, S2 is equal to merge purge of S1, S11. S2 is equal to merge purge of S1, S11. We know that S1. We know S1. How to find S11? S11 is equal to what? What the pairs that we can get in S11. So, how to find this one? P minus Pi, W minus Wi. Here I is 2. So, that's why P minus P2, W minus W2 should belongs to S1. Should belongs to S1. Now, that is P minus P2, W minus W2 must be equal to either 0, 0 or this must be equal to either 1, 2. Now, in this case, what I am getting? P is equal P minus P2, W minus W2 is equal to 0, 0. That is, P is equal to P2, W is equal to W2. What is P2 value? P2 value is 2. What is W2 value? W2 value is 3. Here we will get a pair 2, 3. Now, in the same way, P minus P2 is equal to 1. W minus W2 is equal to 2. Here from this, P minus P2 becomes 1. W minus W2 becomes 2. Now, P is equal to 1 plus P2. That is, P2 value is 2. P becomes 3. W is equal to 2 plus W2. That is, 2 plus 3, which is 5, less than or equal to capacity. So, we'll get a pair 3, 5. So, here S11 means 2, 3, 3, 5. By merging S1, S11, we will get S2. Now, S1, what is S1? 0, 1, 2 is S1. What is S11? 3, 2, 3, comma, yes, right, this one is 6. 2, 3, comma, since that is 4. 2 plus, this is 3. Right. Now, here we will get this as 2, 3 and 3, 5. So, by merging these two, we will get the set S2. In the same way, we can find the set S3 also. We can find the set S3 also. Now, after finding all those sets, how to calculate the values of x1, x2, x3? Let us see. Here, I already find the value of x0, x1, x2 and x3. Now, for I is equal to 3 to 1, in the bottom up way, we are going to find the values of x1, x2 and x3. Now, how to find those values? First, here I take 3 values, 3 to 1, that is I value is 3, I value is 2, I value is 1. Now, first I am taking I is equal to 3. We take the last pair, we can take the last pair in the S3. What is the last pair in S3? 6, 6 is the last pair in S3. Now, if 6, 6 not belongs to S2, if 6, 6 not belongs to S2, that is the profit weight pair 6, 6 is obtained because of third object only. If it is present in S3, but it is not present in S2 means, the third object is not present in S2 means, the 6, 6 pair is obtained because of third object only. So, in this case, if it is true, in this case, x3 becomes 1. x3 becomes 1. So, x3 1 means I placed that x3 into the knapsack. So, its weight is reduced. We need to reduce its weight from the capacity. So, I removed the total profit and total weight. I removed its profit and its weight. So, by removing that, we get 2, 3 which belongs to S2. That 2, 3 should also belongs to S2. Now, for I is equal to 2, we need to take the pair 2, 3. So, what we obtained here? Now, 2, 3 belongs to S2. If 2, 3 also belongs to S1 means, the 2, 3 pair obtained because of x1, not because of x2. If it is not there in S1, in that case only it is because of X2. So, if this condition is false, we take X2 as 0, but this condition is true, then X2 becomes 1. So, here 2, 3 does not belongs to S1. So, since this condition is true, we can say that X2 is equal to 1 and we can omit its profit and weight. We will get 0, 0 which belongs to S1. Now, for I is equal to 1, 0, 0, we are taking S1. If this pair is present in S0, if this pair is present in S0, this pair is not from X1 object. Okay, since this pair is not present, it is present in X1. Since this condition is false, here X1 becomes 0. So that is the answer that we are getting is X1 is 0, X2 is 1 and X3 is 1. X3 is 1. Now, how to calculate their profit and weight values? Sigma W1 X1 plus W2 X2 plus W3 X3. Now here, since X1 is 0, its weight is, what about the weights of those? Let us see, the weights of those 3 are 2, 3, 3 and profits of those 3 are 1, 2, 4. So, 2 into 0 plus 3 into 1 plus 3 into 1 which is equal to 6, which is less than or equal to capacity. And coming to profits, P1 X1 plus P2 X2 plus P3 X3. Here there is no need of writing sigma. Now P1, which is nothing but 1 into 0 plus 2 into 1 plus 4 into 1 which becomes 6, which is the maximum profit that we can earn by placing the second object and third object into the knapsack. I hope you all understood the 0 by 1 knapsack problem, how to solve this 0 by 1 knapsack problem using dynamic programming. Now I am going to summarize the concepts what we explained in this session. In this session we explained what is fractional knapsack problem and what is 0 by 1 knapsack problem. That is, what is the difference between fractional knapsack and 0 by 1 knapsack problems. We seen the problem statement and also we seen how to solve 0 by 1 knapsack problem manually. Also we seen two rules which are implemented in dynamic programming to solve 0 by 1 knapsack problem. Those two rules are nothing but merging rule and purging rule. After that we see the algorithm for solving 0 by 1 knapsack problem. To assess yourself, here I given some questions. Please answer these questions. The first question is, in 0 by 1 knapsack, option A, xi value is 0, xi value is 1, option C, xi value is either 0 or 1, option D, xi value lies between 0 and 1. The next question is, merging rule is used to, option A, to obtain Si plus 1 from the sets Si and S1i, to obtain Si from the sets Si and S1i, to option C, to obtain Si plus 1 from the sets Si and Si, option D, none. The next question is, purging rule is used to, option A, to eliminate the profit weight pairs that reduces profit, option B, to eliminate the profit weight pairs that increase weight, option C, to eliminate the profit weight pairs that reduces profit and increases weight, option D, none. The next question is, solve the following knapsack problem by following dynamic programming algorithm design technique. Here I given 4 objects and the capacity of knapsack is 40 and the profits of 4 objects and the weights of 4 objects. Implement algorithm, dynamic programming algorithm to solve this knapsack problem. In preparing this this presentation, I used the digital content from various public sources. It is only used for educational purpose and not for the commercial purposes. Thank you for listening the session.